Recently, I came across a phrase that stopped me cold: a different kind of business physics. I ran into it while analyzing some videos about AI coding companies, but the company isn't really the story. The phrase is. Because I've talked about that idea before in a slightly different way. And the current version of it is going to turn up in your own vendor conversations sooner than you think. Let's talk about why. Welcome to the Enduring Advantage podcast. I'm your host, Zachary Alexander, and this show helps physical asset operators get ahead of the AI revolution, not just survive it. We've talked about this topic, a different kind of business physics, before in relation to the drone maker posture. The drone maker posture is an asymmetric business strategy modeled on modern drone warfare. The strategies that let resource-constrained organizations actively compete with Tier 1 players in any market. In military terms, a high-priced weapon system is valuable, not just because of the capital needed to produce it, but because it's purpose-built to fill a specific niche no other ordnance occupies. Now you say, why can't you use something else? You can, but like using a hammer to bang in a screw, the results may essentially be the same, but they will look differently. Using a drone to take out a full fuel truck looks a lot different than using a missile to take out that same fuel truck. That results in the collapsing of a civilian housing project. You may not be able to achieve the same goal without any wasted motion. Externalities matter when conducting military operations. An exquisite fighter jet, a precision-guided missile, a smart bomb. They win by being the best club in the bag for a specific job. Even though they're expensive, scarce, and take time to replace, they still have the highest likelihood of achieving the mission goals within the mission parameters. Every one of these is precious, not just because of the unit cost. They matter because no one has an unlimited budget, especially when trying to hide the economic impact. And governments are always trying to hide that economic impact of warfare. So you build as few as necessary, and you protect them. You plan their deployment with care. A drone doesn't play that game. It wins by being small and cheap. You build a lot of them, you deploy them fast, and you learn from the results. You throw so many at a given problem that it's impossible for the defender to keep up. We call that threat saturation. And when one goes down, you carry on the fight with similar mission assets. That's not a lesser version of the exquisite weapons game. It's a different kind of business physics entirely. A different way to win. I bring that up now because I just spent a stretch of time inside two videos about Michael Terrell and Cursor, his AI coding company. And one of the narratives he used was that exact phrase, a different business physics, to describe what Cursor did to the software industry. Not a metaphor I was looking for. He used it as a bolt-on strategy. What I think of when I think of a drone maker posture, a different business physics, one that does not rely on being a monopoly or on being the brightest or being the biggest competitor in the space. When I think of a new kind of business physics, I think of something Boris Cherny said. He runs Claude Code at Anthropic. His rule, build for the model 6 months out, not the model you have today. Claude Code's own early version proves that rule the hard way. For months, it barely worked because it was built for a level of autonomous, multi-step tool use the models hadn't reached yet. Cherny tells the founders this directly. Your product market fit won't be very good for the first 6 months. But if you build for the model 6 months out, you're going to hit the ground running once it catches up. He doesn't leave that abstract. Two things he bets on will keep moving. Tool use and computer use keep getting better. That's Anthropic's own stated roadmap. Coding tool use to computer use. So betting on the next stage is a bet on a trajectory the lab is already executing against. Another example, the unintended run length keeps growing. What that means is that the time you can leave Claude on its own keeps expanding. Sonnet 3.5 could run maybe 15, 30 seconds before it went off the rails. Opus 4.6, which is what the videos were, basically based on, could run 10, 20, 30 minutes unattended. Now we're running Opus 5 with slightly less capabilities than Fable 5 at a significantly lower cost. Some tasks run for hours or days, a few weeks. Claude Code's own scope grew exactly on that curve, not because somebody redesigned the product. Early versions only automated small pieces, Git operations, for example, because the model couldn't yet be trusted with the sustained autonomous coding. The product's reach expanded exactly as that one capability did. Trustworthy, long horizon autonomy caught up. As that capability caught up, Claude Code caught up. Cherney doesn't caveat this. People inside a lab see the specific ways a model's about to improve before the rest of us do. And he calls that edge a little unfair. Fair enough. But you don't need lab access to run that discipline. You need to stop asking what a vendor's product does today and start asking what will it be able to do by the time you've already deployed it or by the time you're ready to deploy it. That's the same physics as building a drone instead of an exquisite weapon system. You're not aiming at where the market is standing. You're aiming at where it's going to be. I used a phrase a minute ago without defining it, and it's the one doing the most work in this episode. The phrase is bolt-on. The Enduring Advantage framework treats this as two different ways of seeing things, not two opinions. Bolt-on Sight looks at AI and sees a feature you add to what you already have. The categories stay put, the org chart stays the same, the workflow stays put. You attach capability to the side of the business and you're done. Versus AI native views, which see something else. Categories dissolving and functions reorganizing around them. Where Bolt-on Sight sees a snapshot, the AI native view sees a trajectory. That's the entire difference between the two. And it's the same difference Cherney was describing a minute ago. He just said it in a product development language. Building for the model you have today is a snapshot. Building for the model 6 months out, where capabilities double every 6 months, is a trajectory. Here's why I'm stopping to name it. Everything left in this episode is the same shape, a compliance program bolted on to an AI deployment versus governance built into the architecture. A skill dropped into a system. Skills, by the way, are kind of like scripts that run AI functionality. So you can have a given skill that will do the same thing over and over again. So we call them Claude skills, but basically everybody is now latching onto that, and all of the models are using that because it's a way of automating a given task versus a skill which evaluates before it loads. Now we call that enterprise inference hooks. Same question every time. Is this thing attached to the outside or is it structural? Once you hear that question, you can't stop hearing it. And it's the most durable thing I can hand you today because it works on vendors you haven't met yet, about products that don't exist yet. You can watch that same split sitting inside a word everyone is fighting over right now: governance. If you spend an hour in any AI governance training course right now, you get the same architecture every time. 6 principles: accountability, transparency, fairness, privacy, safety, and alignment with organizational values. The most important 5 frameworks are stacked on top of them. ISO 42001, NIST AI Risk Management Framework, the EU AI Act, the OECD principles, UNESCO's recommendation, and a case study to prove it isn't theoretical. A bank's critical scoring system walked through risk management, bias testing, a documented audit trail, and a governance officer signing off before it ever reaches a customer. The course's own argument, repeated in almost every section, is that governance builds trust. Nothing that follows is an argument against it. But we use the word governance on this show with the Enduring Advantage framework differently. And we mean something that shares nothing with any other except the spelling. In the Enduring Advantage framework, governance isn't a committee, it isn't a policy document, it's an architecture. We break it into the protection bubble, that enforced boundary around your institutional knowledge, and your plug-in authority deciding who gets to talk with what. However, we now have another player that sits out also inside that bubble. It doesn't actually cause us to increase the number of components. We still have the same components. We have a MCP identity center, an MCP metadata registry, and an MCP identity provider. But inside the registry, we've added Claude Enterprise Inference hooks. Claude Enterprise hooks do not inspect, modify, or govern the final response returned to the user. They allow or deny decision on request-side content before inference. This is where the things get very interesting. With the introduction of Claude Enterprise Inference hooks, you have to deal with data loss prevention tooling. DLP gives go, no-go decisions about MCP requests. The architecture as it stands now surrenders the DLP tooling to a third party. However, a drone maker posture would have it included in the MCP metadata registry. Basically, what this means is that the registry could use the DLP tooling as part of a denial of service mitigation strategy. I don't want to go too deep because it's a very recent capability. However, in 6 months, we could see this become part of the AI foundation of all AI infrastructure. Governance depends on someone doing the right thing at the right moment, and it fails the moment someone doesn't. Architectural governance doesn't ask anyone to remember anything. The boundary holds whether or not the person or shift that day is paying attention. Both get called governance. Only one of them is still standing on the day after the next riff or reduction in force. Carry that distinction into your own vendor conversations. When someone tells you their AI platform is governed, safe, compliant, audited, ask them what they mean. A compliance binder and a signed policy are worth having. They are not the same thing as a boundary the software itself enforces. One that holds even the day nobody's checking. One depends on discipline. The other doesn't ask for any. Here's the thing that's going to be a live argument 6 months from now, and it's worth understanding before it is. When you install a skill, a set of instructions that tells an AI model how to do a particular job in your business, there is exactly one question that determines whether it's governed. It isn't who wrote it. It isn't what you paid for it. It isn't whether the vendor has a security certification. The question is there an evaluator? Is there something in your architecture that decides whether that skill is allowed to load before it loads? If there is, the framework is called a bound skill. If there isn't, it's an unbound skill. And here's the part that catches people. A skill your own team wrote in-house yesterday by someone you trust completely, that's an unbound skill. If nothing is evaluating it before it loads. The word is unbound isn't a judgment about where the skill came from or who made it. It's a description of whether anything checked it. Going forward, there's going to be a real need for DLP or data loss prevention tools. Now, why does that matter so much? Because a skill isn't data, it's instruction content. And instruction content can change how the model does something it was already allowed to do. The framework has a name for that: procedural corruption. And right now, the only things we can do is topological and not no-go denial of service mitigation. Procedural corruption assumes the action is permitted. It attacks the method. Picture how that actually plays out. A skill body reaches your model carrying its own mandate. Before you call that model, that tool, you read it first. Nothing evaluated whether it was entitled to make that claim. No authorization boundary gets crossed, so the intersection check never fires. No decision trace records a violation because technically none occurred. Every individual action was authorized. The procedure that produced them was corrupted. That's why it gets its own category instead of being folded into authorized access. It isn't someone doing something they weren't or aren't authorized to do. It's your own people doing exactly what they are allowed to do. It may be someone hijacking that communication, but it's allowed in a way that was written for them by something nobody checked. Let me show you how that check actually works, because the design is more careful than it needs to be. And the care is the point. When a skill tries to load, it doesn't hand over the skill. It hands over a reference, an identifier, a version, fingerprint, who's asking and in what context. That reference goes to the authorization layer, which captures it against a policy. This operator's authority intersected with what this skill is permitted to do, load or refuse. Notice what didn't happen here. The authorization layer never read the skill. For most AI systems used in business contexts today, there's never anything to determine if a skill tool is supported. Now, before the skeptics can chime in, OAuth 2 is supported by most remote MCP servers. However, this support is more about who is going to pay for the token usage. When you say, I agree to authorize the actions of my agent, what you're really saying is, I agree to pay for whatever resources my agent consumes. What should sound alarming is that it isn't asking, is this skill safe? It isn't asking, may this skill load for this person? In this context right now, whether the context is even good is stored anywhere else. There is a version fingerprint. However, it does more work than it looks like. A binding doesn't name a skill. It names the exact version of a skill by fingerprint. Swap the contents at a registered address and the fingerprint stops matching. The load fails on arithmetic rather than on trust. Nobody has to notice the substitution for it to fail. Now, the part that reorganizes most people's mental model, including mine when I first worked through it, say you got an unbound skill running and something changes. The vendor is compromised. The skill starts misbehaving. An operator leaves the company. You're stuck. There's no centralized location like an iOS App Store or Android App Store that polices the activity of skills. No one is being reckless. It's just the way things work right now. There was a time when people used to contact their banks on mobile phone lines without encryption. They would do stock transfers. I believe in this next 6 months, nobody will use Claude skills or any other frontier model skills without DLPs.